root of 9 times 3 square root of 2.
Is it 54 square root of 2?
You said 54 square root of 2?
Yeah.
Yes, that is correct.
Okay.
Awesome. All right, so let's look at next problem here. Wow, it's almost like this was an afterthought. Is this square your work or is that the teacher's work?
Which one?
On number 6. I'm seeing like this square off to the side. Is that you or is that?
Yeah, that was me.
Okay, so let me not snip that in here. So let me just write the problem the way it was meant to be written. Square root of m to the 15th over 72. Okay, your squaring is a good strategy if you're solving. You're not solving here. You're simplifying, which is it's a little bit different. You want to break this apart into the square root of the top, square root of the bottom, like this.
Okay.
Is that clear?
Mm-hmm.
Okay, now on the bottom here, I think we've done this a number of times, like 2 and 36, 2 and 18, 2 and 9, 3 and 3. You can bring out a pair of 2s. You can bring out a pair of 3s.
Mm-hmm.
All right, so that's a 2 out, 3 out. So it becomes 2 times 3 on the outside, square root of what's left over on the inside, which is a 2.
Okay.
So 6 root 2 like that.
Okay.
Please let me know if any of this needs some more explanation.
So what happens to the m square or m15?
Yeah, so in pieces, right? What we just did is the 6 square root of 2.
Mm-hmm.
And then on the top here, we will deal with this, but just, that part is clear.
Mm-hmm.
Hopefully. Now, there's a couple of ways to show this in the top, and I mean it's like we could do our own sort of lesson on just this. This becomes the square root of m to the 14th times m to the 1 in here.
Mm-hmm.
Is it clear? Is like the 14 and 1 add up to 15? That's how I'm doing that.
Yeah.
The square root of m to the 14th you can do separately from the square root of m. Basically break them apart like that.
Mm-hmm.
So on the left here, the square root cuts this exponent in half. Okay, like if it were, since it's 14, it becomes m to the 7th
Mm-hmm.
times the square root of m. So the numerator works out m to the 7th square root of m.
Okay.
Let me know when you're kind of caught up here. There's just a tiny bit more to do on this problem.
Yeah, I'm ready.
Okay, so I'm just going to kind of reset here. We're at this part right here.
Mm-hmm.
You have to rationalize the denominator.
Okay.
So you do that by multiplying the top and bottom by the square root of 2. Whatever you're taking the square root of on the bottom, so you multiply the top and bottom by the same thing. The bottom becomes the square root of 4, 6 times the square root of 4, the top becomes the square root of 2m. Like what's under the roots kind of sneak together, multiply together.
Okay.
On the bottom now, the square root of 4 is 2, so we can write that as a number. And so we're finally done here. Done. What I said. Tired. M to the 7th square root of 2m over 12.
Okay.
All right. We should probably do another one like that. We kind of get it in 8. Maybe we'll just go to 8. That'd maybe be a better way, better use for our time here. All right. You snip 8 in. All right. So this is really 4 separate problems. It's the square root of 75 times the square root of a to the 8th times the square root of b to the 11th times the square root of c to the 6th.
Okay.
Okay. Now for the even exponents, those are great. It's a to the 4th and c cubed. You just cut them in half. Somehow, and you said you typically get a note card.
Yeah.
That might be something to put on there, that you're going to cut it in half or reduce by 2, like that. All right. So that leaves the square root of 75 and the square root of b to the 11th. Square root of 75, I'd like you to come off to the side here and reduce this for us, please.
So it'd be 25 and 3.
So 3 and 25. You'll notice I always use the smaller number, the prime number on the left. And what does 25 become?
5 and 5.
5 and 5. Okay. Now, are there any pairs there?
The 2 5s.
Yes. So it becomes 5 square root of 3. This square root of b to the 11th here, we want to look at that as b to the 10th times b to the 1, and then take the square root of each of those.
Okay.
What does the 1 on the left here become? What is the square root of b to the 10th?
It'd be 5.
B to the 5th, square root of b.
Okay.
All right, so now, like, we're really there. We pretty much have it. It's disorganized. So you group all the stuff that goes outside the root and all the stuff that goes inside the root. So the outside is the 5, the a to the 4th, the b to the 5th, the c cubed. Sorry, this is a b in here, not a 5. Ooh, that's bad. 5, a to the 4th, b to the 5th, c cubed, square root of 3, b, like that.
Okay.
All right. So let me give you a less sophisticated one than this, but it's got some of the same elements, and see if you can work it out. Does that sound fair?
Yeah.
Okay. Square root 12 x to the 7th, y to the 8th. Okay. So same idea. Break it apart in 3 separate problems here, and let me know what you come up with if you got any questions.
Okay. Okay, I think I got it.
Okay. So let me write the answer here. On the outside, there's a 2, x
Mm-hmm.
cubed, y to the 4th. Does that match what you have on the outside?
Yeah,
Inside is a 3x.
yeah,
You got it? Okay,
yeah.
fantastic. All right, so now we can move to 7. Seven's brutal. I know you're in this weird part of the course where I don't feel like this is all very connected.
Yeah.
But nevertheless, this is what we got to work on.
Mhm.
Okay, this one also requires you to rationalize. And normally you just multiply by the square root of what's on the bottom. Okay. But notice in the problem that we did earlier when we did that here, notice that on the bottom here was a product multiplication. In
Mhm.
your problem, it's a sum or a difference.
Mhm.
This is different now. So I'm going to tell you what to multiply by, and then I'm going to explain why. So it's 5 plus the square root of 3, 5 plus the square root of 3. So this is what's called the conjugate. Maybe you heard that in class. The only difference between what I wrote and the original is the operator in the middle. The operator, meaning the minus goes to a plus or the plus goes to a minus.
Mhm.
Okay, and we'll look at that in another example here. But this is what's needed. You have to take the conjugate, multiply the top and bottom by the conjugate, and what happens on the bottom is that it, believe it or not, becomes a numerical value, a nice number. So we'll take a look at that here. So let's just first focus on the bottom here. 5 minus square root of 3, 5 plus square root of 3. This is a FOIL situation.
Mhm.
First, outer, inner, last. 5 times 5 is 25.
Mhm.
Outer is 5 square root of 3. Inner is 5 square root of 3. The last is minus the square root of 9. Do you see any cancellations? Do you see anything that you can get rid of here?
The 2 5 square root of 3s.
They go away. What about the square root of 9? What does that become?
3.
25 minus 3. So this is 22. So the bottom, and this always happens, the bottom always becomes a nice number.
Mhm.
Okay, the top, the numerator is 7 times 5 plus the square root of 3 over 22. You do have to multiply the top. So you know, 7 times 5, 7 square root of 3,
Mhm.
7. So it's 35 plus 7 square root of 3. And then you are supposed to divide each of them by the number on the bottom.
Okay.
This is the way you're supposed to present your answer.
Okay. So would you have to actually divide it by 22, or is
No,
it
that's it. Like this is
okay?
it. I mean, this is the
Okay.
answer. I'd like to give you one to try, or at least get you to do some of the foiling here, if
Mhm.
you're okay with that.
Yeah.
Just because it's a little weird here. So let's go 4 over 3 plus the square root of 2, like this. Okay.
Okay.
what is the conjugate based on what I told you? What changes about this in the
The
conjugate?
3 minus square root of 2.
Exactly. So it doesn't, I don't think you'll see this, but it doesn't matter if like this one's negative, it's only the operator that changes.
Okay.
All right. So what I'd like you to do now is to FOIL the bottom and tell me what you come up with.
Okay. I got -9 minus 3 square root of 2 plus 3 the square root of 2 plus the square root of 4.
So we got some sign errors there. So 3 times 3 is 9,
Mm-hmm.
not positive 9, not negative 9. The
Oh,
next two I heard were okay, minus 3 square root of 2 plus 3 square root of 2. But the last one, and maybe this will help here. And I didn't, maybe, is you treat it as plus square root of 2 and minus square root of 2.
okay.
So that becomes minus the square root of 4.
Oh, okay.
Okay, keep going here. You're almost there.
So then the 3 square root of 2, both of those cancel out.
Good.
And then it'd be 9 minus the square root of 4.
Okay, what
But
does
it'd
that
be, oh
become?
yeah, that should be 2, yeah.
So give me your
9
final
minus
number.
2. 9 minus 2, which is 7.
Good. So your numerator is 4 times 3 minus the square root of 2 over 7. You're almost there. Multiply the top, each thing in parentheses by 4, and then you're going to divide each of them by 7.
Okay. So once I multiply the top, would it be 8 square root of 2?
4 times 3, right?
Is 12. Yeah.
12. Yep. And
Mm-hmm.
then minus 4 square root of 2.
Mm-hmm.
And then you
And then,
divide each of them by 7. So even though you can't like, it doesn't like work out. It's not like it's like, oh yeah, it's nice. You can just leave it like this.
so you wouldn't subtract the 12 minus 4 on the top?
You cannot do that. You can't, they're not like terms. They're,
Okay.
it's like wearing two left shoes. Like it doesn't
Okay.
work. I don't know if you ever tried that. Um, all right. I hear just a tiny bit of uncertainty about this. So we'll do at least the FOIL part again, if you don't mind.
Okay.
Let's go 5 minus the square root of 6 times 5 plus the square root of 6. So will you try working that out for us, please?
Yeah. So on the 2 minus square root of 6 and the plus square root of 6, will those two cancel out?
Yeah, it always works out where the outer and the inner cancel.
Okay.
So if you've got the 5 square root of 6 minus the 5 square root of 6, that's the O and the I. They're always going to cancel, always.
Okay.
So keep going here. Feels like you're pretty close on this.
On the so when I'm folding on the negative square root of 6 and the plus square root of 6, that's what I was talking about. Like,
Oh, I'm sorry. I'm sorry. I misunderstood. Yeah. Just
yeah.
hey, Matthew, you're answering my wrong question here. It is minus because a minus times a plus is a minus. It's if you need to write it out, it's square root of 6 times the square root of 6. Because they're both square roots, it becomes the number times the number underneath the square root of 36,
Okay.
which does reduce to
Square root of 6.
just 6. This one is 25 minus 6, which is
19.
19. Okay. Okay, let's just do one more. Yeah, we can get this here. Let's do 3 plus square root of 6. We just did that. That's no good. 3, let's do that. 3 minus square root of 3. All right, go ahead and try this one, please.
I got for the final answer, I got 6.
Yes, nice. All right, take a deep breath. We're moving on to something new here.
Okay.
Good job on that. So, okay, so the nice thing here is actually 9 and 10 are kind of a repeat of what we just did. So 9 will be good for us to look at here. I didn't realize what was going on here. Okay, so probably the way you will do this on a test or quiz is you will just FOIL this. There's a couple of things you could do to make it a little faster, but I'm not going to worry about that for the moment here. So we're taking 6 square root of 8 and multiplying it by 5 square root of 2. Okay, so you multiply the numbers and you multiply the roots. 30 square root of 16. Is that clear?
Yeah.
Okay. Now for the next one, for the O, there's really a 1 in front of the square root of 3. It's sometimes good to write that because you're going to take the 6 square root of 8 and multiply it by 1 square root of 3. What does that become?
6 square root of 24.
Good. The inner here is minus 3 square root of 2 times 5 square root of 2. What does that become?
It'd be negative 15 square root of 4.
Good. And then the last here, minus 3 square root of 2, 1 square root of 3. What does that become?
It'd be negative 3 square root of 6.
Very good. All right. We're doing really good, but there's more to do here. It's like, oh man, it's like it's just the more you do math, the more there is. What's nice here, though, what I see, and I want you to see this as well, is these aren't too bad. Square root of 16, square root of 4. You know those values.
Yeah.
That's 30 times 4, 15 times 2.
Yeah.
Okay, that's good. 120 and 30 here. This square root of 24, though, with the 6 out in front, you have to reduce that. Okay, or you have to at least try. So we're going to come over here off to the side. Will you try reducing that for us and let me know what you come up with?
Yeah. I got 2 square root of 3.
Okay. Close, really close here. So we've got 2 and 12, 2 and 6, 2 and 3. So the 2 definitely comes out, but anything that doesn't have a pair stays in square root of 6 because 6 is the 2 times the 3.
Oh, okay.
Okay. So now the 6 on the outside, it's 6 times the 2 square root of 6. Okay, which means you're going to multiply the 6 and the 2. So that's why I kind of left it off to the side just to deal with it later. 120 plus 12 square root of 6 minus 30 minus 3 square root of 6. Okay, so we got 120 minus 30. What does that become?
90.
Okay, so you've taken care of those like terms. Now you've got, let me use a different color here. You've got root terms, positive 12 square root of 6 minus 3 square root of 6. This is when you can combine the numbers in front because they're both root 6s. It's like 12x minus 3x.
Yeah.
What does that become?
It would be 9 square root of 6.
Very good.
Yeah.
You got it. So I'll just kind of, and I'm going to probably sound really repetitive. It's like there's probably nothing in here one line at a time that you don't know how to do. It's like putting it all together. Okay. It's like most things in life. It's just hard. So 10, what's good about 10 here is 10 is kind of like starting at this line right here, basically. Okay. So we'll just work it in pieces. So some students even just imagine like it's 4 separate problems. Okay. Unlike the previous problem though, none of these work out, perfectly. It's square root of 32. You got to come off to the side and break apart or come here. So could you try breaking that down for us, please?
Yeah. Would it be 2 square root of 4?
So 2 and 16, 2 and 8, 2 and 4, 2 and 2. Does this look like your work?
No, I did 2 and 16, 4 and 4, and then 2.
Okay. So you keep trying 2 until it works. You just, okay. If something keeps working, you just keep trying it over and over and over again.
Okay.
You circle pairs, which brings a 2 out for each of those. That becomes 2 times 2 square root of what's left over, which is 2. That's just the root 32 part. Then you bring this other 2 down on the outside.
Okay.
So the net result is 8 square root of 2. Okay. Let's do the same thing for this middle one here. I want you to try reducing the square root of 18 for us, please.
Okay. It'll be 3 square root of 2.
It is 3 square root of 2. And then you bring this minus 5 down.
Mm-hmm.
So it becomes minus 15 square root of 2.
Okay.
So kind of our, working it, putting it all together, at least through 2
Mhm.
parts, you're doing okay. 6 square root of 5. All right, take a breath here. Doesn't do anything. But the last one does. So I want you to try this, working out this
Okay.
last one, please.
It'll be the final one be 22 square root of 5.
Yes.
Okay. So, would you just not break down the 6 square root of 5 because 5 can't be broken down?
Said perfectly. Yes.
Okay.
So now what can you combine here?
Um, the 6 square root of 5 and 22 square root of 5. And the, oh wait, yeah,
Okay,
can you
I
do
agree.
the,
Yep, I
see
agree. So what does that become?
it would be negative 7 square root of 2 and then 28 square root of 5.
Good. I didn't keep track, but that was probably like a 6-minute problem or something. These are not short.
Mm-hmm.
So test is on Tuesday, is that right?
Yeah.
Okay, so you have some time in class to get some more practice on this.
Mhm.
Can we move to 11
Yeah.
or? All right.
Mm-hmm.
So starting at 11 is stuff you're going to see in geometry, but kind of in the middle to later part of the year.
Mm-hmm.
And I guess they're just previewing it.
Yeah.
So, so what we've got here is, and you probably saw this in class, Pythagorean theorem. Have you heard of that before? A,
Yeah.
B, and C. A
Mm-hmm.
squared plus B squared equals C squared. It's kind of amazing that this actually works. Are you allowed to use a calculator?
Yeah.
Okay, so making sure this would be about to be tough. So think of this as A, this is B, and this is C. 21 squared plus 72 squared equals T squared.
Mm-hmm.
So can you square 21 for us, please?
Yeah. Be 441.
Plus,
5,184.
okay. Um, you guys must be doing this a different way. No, maybe not. This one must work out nicely. I was trying to decide here. Yeah, 5,184. So add them together.
5,625.
Okay. And then see if you can take the square root of that.
Okay.
See if that works out perfectly, like no decimal, basically.
Yeah, it'd be 72.
Try again. So you're adding these together, right? 5, 6, 2, 5, and then you're taking the square root of that.
Wow, 75.
Yes. Okay. Any questions on that?
No.
All right, let me have you try another one here. We'll call this P. So I'd like you to do the same thing here to find P.
Mhm.
It's still a squared plus b squared equals c squared.
I got P equals 34.
You got it. Well done. Okay, the next two questions. Let me see. Determine whether each set of measures can be the sides of a right triangle. You must show your work and explain why you came to your conclusion for credit. All right. So this whole like a squared plus b squared equals c squared. This works because a is less than b is less than c.
Yeah.
Okay, so like on the left here, these are in ascending order,
Mhm.
increasing order. So this is a, this is b, this is c. So what you're tasked with here is deciding if 24 squared plus 45 squared, does that equal 52 squared?
Okay. It doesn't, right?
I'm sorry.
It doesn't, right?
This one does not. No, this is a no.
Okay.
Okay. Now on the next one, the problem with the next one over here on 13 is you can't necessarily assume that it's in like ascending order. Okay.
Mhm.
Like I know that the square root of 12 is smaller than 4. Not sure how it compares to the 2 times the square root of 7. So this is where you might first put those in the calculator just to see what the numerical values are.
Okay.
So what did you find out here? What's the square root of 12? What's 2 times the square root of 7?
The square root of 12, I got 3.46.
Okay, and the square root 2 times the square root of 7?
5.29.
So in this case, you know, A is the smallest, or I'm sorry, square root of 12 is the smallest, B is 4, and then C. It doesn't quite matter. You're still going to go 4 squared plus the square root of 12 squared. Does that equal 2 square root of 7 squared? But you could get a problem on a test or quiz where they're not in that sort of increasing order here. So just a reminder here, when you square a square root, it does undo it.
Yeah.
On the right here, you square both of them. So 2 squared is 4, square root of 7 is 7. Does this work?
Yeah.
It does. So you can't go by, you know, looks. You gotta inspect here. Things like that. Any questions on that before we move on here?
No.
I'm shocked here that you're doing, you know, 14, 15, 16. Like these are way out of scope for your class. Did your teacher preface this by saying like, hey, you know, this is a preview of what you're going to see in the next class?
No, I think it's just a lesson that's in this like whole chapter, I guess.
All right. Got to ask why. I always ask that. Doesn't make sense to me. All right. So first thing I'd like you to do is find C. So this is like that earlier problem where you found T, then you found C or P, I guess. Could you find C for us, please?
Okay. I got 17.
Good. Okay. Sine, cosine, and tangent. Sine, cosine, tangent. Sine of y. Y is an angle. So y really represents like the degree measure here, which we don't know what it is. We could figure it out, but not in this problem here. But we could figure it out. So there's this acronym you might have seen. Lots of ways to remember this. You got to TikTok. I just remember it as is. There's a slightly better way to write this, which is I'll put down here SO divided by H, CA over H, TO divided by A. Okay. Now, your sine of y here is the opposite side relative to y. Okay. So the opposite side is this 8. Okay, good. I didn't know how clear that would be. The hypotenuse is always the longest side in the triangle.
Yeah.
Which is 17. Cosine is A or adjacent. Now, adjacent refers to a leg. It never refers to the hypotenuse. Like relative to y, you might think, wasn't 17 adjacent? Well, it kind of is, but it's actually the hypotenuse instead.
Yeah.
Okay, so this one is 15 over 17. Tangent of y is O for opposite, 8 over adjacent, which is 15. So this might be good to have on that note card there. It also sounds like you kind of know this, which I'm shocked, not because it's you, just because like, again, like can't believe they're showing to this in Algebra 1. Any questions on that?
So would that be the final answer?
That's it.
Okay.
All right, so let's have you do one here on your own. Let me just make up a slightly different problem. We're basically hitting the buzzer here. But let me give you a quick triangle here. Let's say this is y, 3, 4, 5. Can you give me sine, cosine, and tangent, please,
Okay.
of this? Do you have anything here for me?
Almost.
Okay.
So for sine, I got 4/5.
Yes. Good.
And
Cosine.
then cosine, I got 3/5.
Good.
And I got 4/3 for tangent.
Perfect. All right. Good job. Let me stop the recording here.